Looking for a really fast way to build a mobile app on top of MongoDB? OutSystems makes it easy and fast. Learn how on this episode of Decoded Quick Hits. In our last Quick Hits episode, we talked about MongoDB, the document-based NoSQL database, and how you can use the MongoDB connector from the OutSystems Forge to connect to your MongoDB database and read and write those documents. So you have a shiny new MongoDB Atlas account, and you're ready to build some apps. OutSystems is a great place to start because our high-productivity development platform goes hand in hand with the flexibility of MongoDB, allowing you to have a tight cycle of developing ideas, publishing them quickly, getting feedback from stakeholders, and rapidly bringing that feedback into your application, and publishing new versions to satisfy user requests. In this episode, we'll build a simple mobile app that takes advantage of the flexibility of MongoDB to create the beginnings of a self-service portal for employees to provide the status of equipment they're using for working from home. We'll approach this app in a series of steps: configuring the MongoDB connector, defining one or more structures on the OutSystems side to define our data model, creating the screens and action flows to read and write the data using the MongoDB connector actions, updating our data model and UI to reflect feedback from stakeholders, and publishing the updated app at each step of the way. Let's get started. In order to get started with our app, we'll need some information from MongoDB. For this demo, I've set up a free MongoDB Atlas account and a cluster called ProtoMongo. On the management page for my cluster, I can view the connection information and the collections and databases that are stored in the cluster. When I click the Connect button, and then I click Connect Your Application, I can see the connection string information I'll need when setting up the MongoDB connector on my OutSystems environment, which we'll do shortly. If I click the Collections button, I can see all the databases I currently have set up, along with the collections they contain. The collections are where related sets of documents containing my application's data are stored. You can see I have a variety of databases already, which are a mix of demo apps I've written and sample databases that MongoDB provides for testing and prototyping. Once you've found your connection string info, it's time to head over to OutSystems Service Studio. If you aren't already an OutSystems user, you can sign up for a free account at try.outsystems.com. We'll include a link in the description as well. In Service Studio, once I've signed into my development environment, my next step is to use MongoDB is to download and install the MongoDB connector, which I can do from the Forge tab of Service Studio. I'll just type MongoDB and click Search, and the first thing that comes up is the MongoDB connector. Clicking the card displays all the information about the connector and provides an install button. As you can see, I already have this installed, so I see a check mark and the installed text instead. For the sake of time, I've gone ahead and created a new phone app using one of the built-in templates in Service Studio. To get the MongoDB connector wired up, we need to add a few site properties, which allow us to store values on the server side of our application, and then plug them in as needed. It's important, especially with sensitive information like connection strings, that we never store such information on the client device, since it's much easier for bad actors to compromise data stored on the client. To set the site properties, we'll use the Data tab on the right, and right-click the Site Properties folder, and click Add Site Property. We'll add site properties for collection name, database name, and connection string. We can set a default value for each if we like, but the advantage of using site properties is that we can configure the value for each environment, development, testing, or production, using the Service Center management tool. Once added, we'll publish the app using the one-click Publish button, so the site properties will be available for editing in Service Center. Now that the publish is complete, we can access Service Center for development by clicking the gear icon in the toolbar. This will take us directly to the relevant application. Here in Service Center, you can perform a number of tasks related to the applications and modules you've created. For this app, what we need is the Site Properties tab. When I click that tab, you can see that the site properties we created in Service Studio are already available. I can click each site property name and provide an effective value for the current environment. In this way, if I need to have a different connection string for development versus production, I can easily manage that separate from the application itself. I'll set the collection name to Employee Self-Service. Click Apply. I'll set the database name to my equipment, click apply, and then plug in the connection string information from MongoDB. Now we're ready to head back over to Service Studio and continue creating our app. Although we've installed the MongoDB connector in our development environment, we still need to tell the app where to find it, which we do using dependencies. To manage the dependencies, I'll click the plug icon in the toolbar, then search in the left side for MongoDB. I'll then select MongoDB Core and click the top checkbox on the right to make all of the actions available to my application, and click Apply. Next, we'll start modeling our data. One of the nice things about working with MongoDB compared to a more traditional relational database, especially early on in the development process, is that MongoDB provides great flexibility in terms of the shape of our data. So if we need to modify the data model, that doesn't always need to slow us down at all, which isn't always the case with relational data. To work with the data on the OutSystems side, we'll use structures, which are in-memory representations of data and can be used to scaffold and bind UI widgets for our app. I'll create a structure by right-clicking the Structures folder, clicking Add Structure, and name the structure Equipment Item. Then I'll add attributes for ID, name, and serial number. Note that serial number defaults to the integer data type, which we'll want to change to text. One important note when it comes to working with IDs in MongoDB is that MongoDB defaults to the use of _ID for the unique identifier of a given document. If you want to use this identifier in your structure, you simply need to click on the ID attribute in your structure, double-click the JSON ... property, and set the name in JSON property to _ID. For this initial version of our app, we will keep things simple, with a home screen to list all of the equipment items, and a detail screen allowing users to create or edit items. To add the home screen, I'll drag and drop a screen widget from the toolbox, select the empty screen template, and name the screen Home. We'll add the detail screen in a bit. Now's a good time to publish our app again before we start fetching data for our UI. To get data from our MongoDB database, we'll use one of the server actions from the MongoDB connector, and we'll call this using a special action called Fetch Data from Other Sources. I'll just right-click the screen and select Fetch Data from Other Sources, and now I have a logic flow where I can use my MongoDB action. I'll name this Get Equipment Items, and expand it to show the output parameter, which I'll name Equipment Items, which will change its type to a list of the equipment items structure type. Next, I'll switch over to the Logic tab on the right, expand the MongoDB core node and the MongoCrud folder, and locate the Mongo document query action and drag it onto the flow. Note that the Properties panel now shows that there are some required properties that are missing from the input parameters the action expects. These correspond to the site properties we configured earlier, so we can simply add those using site dot and the site property name. Now the Mongo document query action is wired up, but we need to work with the data returned, which will be JSON data, so we'll need to deserialize that into the equipment item structure and add it to a list that the screen can use to display the data. I'll start by dragging the For Each widget from the toolbox onto the flow below the Mongo document query action, and then set the record list to the result of the query. Next, I'll drag a JSON deserialize widget next to the For Each, connect the two, set the JSON string property to the current document, and the data type to equipment item. Now I need to add the items to a list, so I'll grab the Run Server Action widget, drop it below the JSON deserialize, search for list, and use list append, connect them, and set the list to the equipment item's output parameter and the element to the data returned from the JSON deserialize. Now I'll connect the list append back to the For Each to complete the loop. Let's publish one more time, and then create a list UI to display the data. Now we're ready to start displaying our data, and the good news is that creating a list UI couldn't be much simpler. I'll just switch over to the Interface tab, double-click on the home screen to open it, and then drag and drop the equipment item's output parameter onto the screen. This will scaffold out a basic list UI with all the attributes of the structure represented. We don't want to display the ID, so I'll delete that. And maybe we want the name attribute to be bold, so I'll just use Ctrl-B to bold that. You can also fully customize the UI using CSS styles. That's all we need now for displaying the data. But if we loaded up the app now, there wouldn't be any data to display. So let's create a screen to create or edit items. We're going to take a brief detour here to create a helper action that we'll need for our detail screen. When saving data from the client, we start from a client action which does not have access to the site properties, meaning we can't use the MongoDB connector actions directly from the client. So we need a wrapper action to receive the data to be saved. I'll click on the Logic tab, then right-click the Server Actions folder, and click Add Server Action, and name the action Create or Update Equipment Item. And add an input parameter called Equipment Item. I'll also add an output parameter called Equipment Item ID to return the document ID for newly created documents. Inside this action, I'll add a JSON serialize widget and set the data to the equipment item passed in. Next, I'll drag the Mongo Creator Update action from the Mongo CRUD folder onto the flow, set the site properties as before, and set the document JSON property to the JSON return from the JSON serialize widget. Last, I'll drag an assign widget from the toolbox and use it to set the equipment item ID output parameter to the ID returned from the Mongo Creator Update widget. Now we're ready for our detail screen. Back in the Interface tab, I'll start by right-clicking the name expression in our list UI and selecting Link to New Screen. Then again, I'll choose the Empty Screen template and name the screen Item Detail. For editing, we'll need the ID of the item we want to edit. So I'll right-click the new screen and click Add Input Parameter and name it ID. Now I'll go back to the home screen, locate the link widget wrapping the name expression, and set the ID parameter to the current item ID in the list. Next, I'll switch back to the Item Detail screen and use another Fetch Data from Other Sources action to retrieve the data for the selected item. Note that we want to get the latest data in case something's changed on the server since we last retrieved the data. I'll name the action Get Equipment Item by ID and name the output parameter Equipment Item. To get the item data, I'll switch to the Logic tab and add a Mongo Document Get action to the flow. And set the required properties as before. And I'll set the document ID property to the ID passed in from the list screen. Of course, if we're adding a new item, there won't be an ID, and we won't get any data back, so the UI, which we'll create momentarily, will be blank. After retrieving the document, we'll deserialize it and then set the output parameter to the result. Next, I want to create a form to edit or add the data. So I'll switch back to the Item Detail screen, drag a Form widget from the toolbox onto the screen. The Form widget needs to know the shape of the data, so I'll just drag the equipment item output parameter onto the form, and that will scaffold out the fields in the form. We want to let MongoDB handle the ID field, so I'll remove that from the form. The form automatically includes a Save button, and you'll notice that it's bordered in red. This is because we don't yet have an action to save the data. I'll double-click the button to add the Save on Click action. Remember the helper action we created a little bit ago? Here's where it's going to come in handy. The Save on Click automatically includes a conditional or if widget that checks whether the form is valid. By default, this will check whether all values match the type defined for the field, as well as whether all required fields have been filled out. You can also add custom validation logic. It's important to note that client validation is not sufficient for security purposes and is only for convenience. To truly ensure values are safe and valid to be saved, you should include server-side validation in your production applications. The helper action we created earlier in an earlier step is one place we could include additional validation before saving the data to our database. To save the data from the form, I'll switch to the Logic tab and drag the Create or Update Equipment Item server action onto the flow below the validation step, and set the equipment item parameter to the Get Equipment Items by ID equipment item from the data query, since that's what's bound to the form. We could be done here, but this wouldn't provide feedback to the user on whether the save succeeded. So I'll drag an if widget from the toolbox onto the flow and set the condition property to check whether the equipment item ID returned from the Create or Update action is blank. If it's not, then we know the action succeeded. If it is, we know it failed. Then I'll add a message to each branch of the if to alert the user. I'll add an end node to the failure branch and change the end node on the success branch to a destination node and have it go back to the home screen. We need to do one more thing before we're ready to test our application, and that is to provide a way to create a new item. I'll switch back to the home screen, drag an icon widget into the header, and set the icon to use a plus symbol. Then I'll right-click the icon, select Link to, and Item Detail. Because this is a new item, not an existing item, I'll set the ID parameter to the null identifier platform provided value. Now let's publish and test out our app. Recall when we started, we looked at the MongoDB Atlas instance I set up, and the fact that there's no database for the app. Although we've published the app multiple times, until we actually add some data, there still won't be a database in MongoDB, as we can see looking at our collections. Switching back to Service Studio, I can launch the app in a browser-based emulator by clicking the blue arrow at the top of the editor, which replaces the one-click Publish button after we successfully publish. When the app loads, you can see there's no data displayed on the home screen, because no data exists. Let's say we're an employee working from home, and we need to register a monitor we've brought home. First, I'll click the plus icon to go to the item detail screen. Then I can add the name monitor and a serial number. We'll just use ABC123 and click Save. As expected, we get a success message and are redirected to the home screen where we can see the new item listed. And now if we switch over to the MongoDB Atlas management site and refresh the collections, we'll see that the My Equipment database has now been created and contains the Employee Self-Service collection with a single document for the monitor we just added. So we put the initial version of our app in front of the stakeholders, and they spot a couple of obvious things missing. One is a way to tell who has the equipment. We could use user ID and employee ID, or perhaps the employee email for this purpose. We'll go with user ID for this demo, since that information is available by calling getUserID on the client. Note that in a real-world application, we would want to validate this value on the server side to ensure that it matches the ID of the logged-in user before saving data. Another missing piece of data is a way to note whether a given piece of equipment is being used from home. This can be a simple Boolean attribute for purposes of this demo. To implement the change, we'll need to first update the data model, then update the form to include the Boolean field, and lastly, set the user ID value before saving the data. To implement the data model changes, we can simply add the attributes to the equipment item structure like so. To add the Boolean field to the form, I'll just open up the item details screen, expand the equipment item parameter, and drag the Boolean field where I want it to appear on the form. Because the field is a Boolean type, this will scaffold a checkbox by default. Because we have not marked any of the attributes of the equipment item structure as mandatory, we could go ahead and publish this app and it would still work, but the user ID field would be blank. To successfully save the user ID, we just need to add an assign widget before the creator update equipment item action and set the user ID to the current user ID, like so. Now we'll publish again and test the app. When we open up the app in the emulator, a message will pop up indicating that the app has been updated to the latest version. Now, if we add a new equipment item, we should see that the Boolean field is there, and we can check it, save the item, and the value should be saved to the database. Switching over to MongoDB, if we refresh, we can indeed see that that's the case, along with the user ID field, tying the equipment to the specific user who added it. While this is a simple example, it illustrates the advantages of using MongoDB, the speed of developing an app using the visual development platform of OutSystems, and the ability to rapidly make changes in response to user feedback. In this video, you've seen how quickly you can create a basic mobile app on top of MongoDB using OutSystems. Stay tuned for our next episode, where we'll look at how you can create a progressive web app, or PWA, to enable easily installing the app on a mobile device without the use of app stores. If you found this video useful, please give us a like and subscribe to the OutSystems YouTube channel. And don't forget to click the bell icon to be notified when new episodes arrive. Thanks for watching.